Alrighty, in today's video, we're going to be talking about 9.2, which is matrix notation and Gauss-Jordan elimination. Basically, it's another way to solve the matrix from the last section, the systems from the last section using matrices. All right, I'm going to start off by kind of going right into the examples. You can kind of see where the notes are at, but until you really see it in practice, there's a lot of notation that makes it, in my opinion, bog it down a lot. So I'm going to be on page 583 today, and I want to start with number 4. Number 4 says, let D equal this matrix, negative A, 13, negative 1, 0, 6, 3, 0, negative 9, 0. And you're asked to do the certain things. The first thing you're asked to do is determine the order. The order, oh, did I get the right numbers in there? Okay, okay, perfect. Okay, the order here is going to be rows by columns. So a good note to write here. These are rows. These are columns, just like an Excel sheet or sheets, whatever y'all are used to. So you would just have to go, all right, how many rows? I got 1, 2, 3 rows by 1, 2, 3 columns. So the order of D is a 3 by 3. All right. The next thing you're going to be asked to do is determine what is the value of D23. And that basically just means these are the placements. I'm going to use lowercase d since this is capital D. And then when I go D11, that means row 1, column 1. Then I have D12, row 1, column 2, D13, row 1, column 3, D21, row 2, column 1, D22, row 2, column 2, D23, row 2, column 3. Then you have D31, row 3, column 1, D32, row 3, column 2, and D33, row 3, column 3. So that's what these little numbers mean. Is basically the first number represents the row that you're at. Second number is the column that you're at. So I'm looking for row 2, column 3, and that would be 3. All right, let's see this again. Let's look at what is the value of D33. So again, that'd be row 3, column 3, and that value is 0. And that's it. All right, so let's do another one. So let's look at 6. You are given A equals 9, 7, 5, 4, 0, 2. Determine the following if possible. Well, 1, what's the order? So I have 1, 2 rows. That's 2 rows. 1, 2, 3 columns. You might also see people do this: R1, R2, C1, C2, C3 to represent how many rows and how many columns. You can do that if you need to. The next thing is, well, given this, what is the value of A22? So I'd go to row 2, column 2, and that result is 4. Let's look at this next one. What is the value of A13? So it's going to be row 1, column 3. That result is 0. Now, this isn't in the book, but I do want you to see this. So we'll say this is extra. Give me the value of A33. So when you look here, you go row 3. There's not a row 3. So in this case, no solution. All right, so do watch out for something like that on your homework. All right, on the next part, you're going to be asked to now make these matrices. So let's look at number 14. You were given something crazy like this. 2z plus 3 minus x plus y equals z. Then you have negative 3x minus 2y minus 1 equals 5z. Then you have x over 3 minus y minus 2z equals x. All right, what you have to do here to write this in a correct matrix is you have to make sure this is in standard form, which means it goes x, y, z, constant. All of these are out of order. So I want to put these in the correct order. So I'm going to start off by distributing. So that's going to give me 2z plus 6 minus x plus y equals z. I'll subtract the z over, and I'm going to subtract the 6 over. So in this case, putting this in order, I get negative x plus y, 2z minus z would be plus z equals negative 6. That'd be your first one. Now again, I'm going to distribute, so I get negative 3x plus 6y minus 1 equals 5z. So again, I'm going to subtract 5z and add 1. So again, I want to get everything over. When I do that, I get negative 3x plus 6y minus 5z equals 1. Got that one done. Then I got to do the same thing with this one. I get x thirds minus y plus 2z, because again, you're distributing, equals x. I'm going to subtract x over here. So 1/3 minus 1 would be negative 2/3 x minus y plus 2z equals 0. All right. Now that you have all of those values, you're going to write all your x, all your y's, all your z's, and then we have this like little bar here that represents what it's equal to. So for the first one, I have a negative 1, so that's the number that's right here, then a positive 1, then a positive 1, then a negative 6, and then again, just writing the coefficients. This is going to be negative 3, positive 6, negative 5, positive 1. Now I look over here and I have negative 2/3, negative 1, 2, and 0. Right? And then that's pretty much all you got to do. So the hard part is getting them in the correct order and then just writing out just the coefficients. All right. Now, once it's in this matrix, how do we use it to help us solve? So it starts off with your homework on basically giving you commands before you're actually given to do the entire process. So here we go. Let's look at number 26. So you're given stuff like this: 3, 1, 2, 3, negative 7, 5. And you're asked to say or do negative 3, row 2 plus row 1. All right, when it's written like this, what happens is you take the values in row 2 and you're going to multiply it to negative 3, and then you're going to add it to row 1, and then that result will be the new row 1. So if you like, row 2 will not be changed if you want to go ahead and write it out, and then just do that, do the work. So negative 3 times 1 is negative 3, plus 3 gives me 0. Negative 3 times 3 is negative 9, plus 2 gives me negative 7. Negative 3 times 5 is negative 15, plus negative 2 or 7 gives you negative 22. Right? And that's all you're asked to do at first. So let's see some more. Let's look at number 29. You are given 9, 1, -2, 3, 7, -2, and you're asked to do this task. Row 1 switches with row 2. That's what this means. When you have arrows in both directions, you're going to swap the two rows. So in this one, row 2 now becomes row 1, and row 1 becomes row 2. And that's it. All right, so see a different situation now. Let's look at number 40. You have 1, 3, -5, 3, -1, 0, -2, 8, 2, 4, 2, 7. And you're asked to do a couple of things. You're asked to do -3, row 1, plus row 2. And then you're asked to do 5 times row 1 plus row 3. So since I end with row 2 will change. When I end with row 3 will change. So that means row 1 will remain the same. I'll go ahead and rewrite it just so I have it. And then I'm going to just go from top to bottom at whatever order you want to do. Doesn't really matter. So I'm going to do -3 times 1 is -3 plus row 2, which is 3, gives me 0. -3 times 3, -9, plus -1 gives me -10. -3 times -2 is +6, plus 8 gives me 14. Yes. -3 times 4, which is -12, plus 2 gives me -10. Then do the same thing here. Again, using row 1. 5 times 1 is 5, plus -5 gives me 0. 5 times 3 is 15, plus 0 is 15. 5 times -2 is -10, plus 2 gives me -8. 5 times 4 is 20, plus 7 gives me 27. If you have to write out that work, by all means do that, but it's just simple multiplication and addition questions. So something that relatively at this point in your game, you should be able to do in your head. But if you need to do it on paper or write it out until you get more comfortable, that is completely fine. All right, so again, those are just things that the homework is going to tell you to do to kind of gear you up to do it on your own. So let's get into that. Now, I will say, I personally don't like, and I've done matrices. I actually studied matrices in college for like 5 semesters. So I have a lot of information on that, if you ever need extra help. But I personally do not like Gauss-Jordan elimination, because on that one, you have to make two triangles of zeros with a diagonal of ones, and you'll get all of your answers, but it's doing twice as much work when it's just as easy to do uh, Gaussian's elimination, which basically is half of the work and then back substituting, which is what we saw in the last section. So let me start you off with what I prefer, and then I'll show you a different method that you can do as well. If you ever get an opportunity to take linear algebra, you're going to have to know it anyways, so this is your opportunity to potentially see it for the first time. All right, I'm going to jump to question 57. We are given 2x plus 6y equals 4, and -4x minus 7y equals 7. I'll make sure I got the right numbers. All right, so step 1, write it out as a matrix. I'm going to write it out over here. That's going to be a 2, it's a -4, that's a 6, it's a -7, 4, and 7. I don't know why it's coming out at an angle. Hold on. There we go. All right, so I have it right here. So my first objective is I want to get this guy right here. Let's see, what's easier? Personally, I want to get this to become a 1. So the way I'm going to do that is I'm going to divide by that value. So I'm going to say row 1 divided by 2. All right. So when I do that, I'm just going to divide row 1 by 2. That's going to be 1, 3, 2. Now, when you're looking in your book, you might go, hey, I thought you couldn't divide. You could only multiply, add rows together, or swap them. Technically, I'm multiplying by 1/2. So division is a multiplication of fractions. All right. My next goal, so step 1, get that top left-hand corner to be a 1. Step 2, get this to become a 0. Best thing to do is multiply by the opposite of this number to row 1. So in this case, I'm going to say 4 times row 1 plus row 2. So now my result will go to row 2. And so whatever this number is, change the sign, multiply it to row 1. So that means row 1 will not change. So 4 times 1 is 4, plus -4 is 0. That's what I wanted. 4 times 3 is 12, plus -7 is 5. 4 times 2 is 8, plus 7 is 15. All right. The third and final step on a 2x3 matrix, because it gets bigger, is I want to make this a 1. So just like I made this a 1, I'm going to do the same thing with row 2. I'm going to take row 2, divide it by whatever that number is, and that will be my new row 2. So once again, row 1 is not affected. 0 divided by 5 is 0, so I didn't change anything that I've already done. 5 divided by 5 is 1, and 15 divided by 5 is 3. Now that you're in this process, remember that this was your x, this was your y, this is your z. So once you have a diagonal of 1s and a triangle of 0s, then you can write this, not z, sorry. This is what it equal to. I have an equation. So I basically on the second row here is stating that y is equal to 3. And my second equation is x plus 3y equals 2. Because I have 1x, 3y equals 2. But since I know what the value of y is, I can substitute this y. So I now get x plus 3 times 3 equals 2. So 3 times 3 gives me 9. Then I'm going to subtract 2. Oh, I'm off on that one. I'm going to subtract 9, not 2. So I get x equals -7. So my answer, -7, comma 3. This is fun. I like this. Let's do another one. Let's do 60. 6x minus 16y equals 10. -3x plus 8y equals 4. All right. Step 1, rewrite it. So I get 6, -3, -16, 8, 10, and 4. I'm going to turn this guy into a 1. I'm going to do row 1 divided by 6. 6 divided by 6 is 1. 16 divided by 6 does give me a fraction. It would be, what would that be? 16, 6, 8/3, -8/3. Then 10/6 will be 5/3. And then now I'm going to multiply by the opposite of this value to row 1. And I'm trying to get this to become a 0. So I'm going to do 3 times row 1 plus row 2. So this is 3 times 1, which is 3, plus negative 3, which is 0. The first row did not change, so I'm going to go back and write that. 3 times negative 8/3 actually is just negative 8 plus 8, which gives me 0. 3 times 5/3 is actually just 5 plus 4 gives me 9. Now, this is a great example. Last time we saw that we got 1y equals 3. Super easy. Here, you're given 0y is equal to 9. 0 cannot equal 9. So when that happens, there are no solutions. Or, I forget. Nope, that's it. Yeah, no solution. After infinitely many solutions, the one where you have to write it as an equation. And if that's the case, had this been like 0 equals 0, then you would write this equation out and you would have it for the next one. All right, but that's all I got there on that one. So now let's talk about Gauss-Jordan elimination. All right, so let's look at 81. And this will wrap up all. We'll do 81 and another one, and then that'll wrap it up for us. Yeah, doesn't get any better. So we have negative 5x plus 9y plus 3z equals 1. Then we have 3x plus 2y minus 6z equals 9. Then we have x plus 4y minus z equals 16. Step 1, just like always, write out the matrix. Negative 5, 3, 1, 9, 2, 4, 3, negative 6, negative 1, 1, 9, 16. All right, so I could, here's the thing. I want to make this a 1. And I could divide this by 5 and deal with fractions. But notice that one's already a 1. So what I want to do is I actually want to swap these two to make my life a little bit easier for my first step. So I'm going to swap row 1 with row 3. So now I have 1, 4, negative 1, 16. 3, 2, negative 6, 9. Negative 5, 9, 3, 1. All right, my next two steps I'm going to do at the same time. I want to make this a 0, and I want to make this a 0. So to do that, I'm going to do the opposite of this number times row 1. So it's going to be negative 3, row 1, plus row 2. Then I'm going to do the opposite of this number times row 1. So now I'm going to do 5 times row 1 plus row 3. And that will start off a big chunk of my triangle here. So again, the row 1 does not get changed. So negative 3, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 4, negative 12. Negative 12 plus 2 is negative 10. Where am I at? Brain fart. Negative 3 times negative 1 is 3 plus negative 6, negative 3. Negative 3 times 16, negative 48. 16, 32, 48, negative 48 plus 9, negative 39. All right, keep going. 5 times 1 is 5 plus negative 5, 0. 5 times 4 is 20 plus 9, 29. 5 times negative 1, negative 5 plus 3, negative 2. 5 times 16. Hold on. Let me pull out a calculator. How's that? 30, 80? Is that 80? I think that's 80. So that's 80 plus 1. So 81. All right, next goal is I now want to make this guy a 1. Well, it's going to give me fractions. How can I avoid it? There's nothing I can think of that's going to avoid these fractions. All right, here we go. So I want to make this guy a 1. So I can make that guy 0. So it's going to be row 1. Oh, I lied. Row 2 divided by -10. So 1, 4, -1, 16. 0 divided by -10 is 0. -10 divided by -10 is 1. -3 divided by -10 is 3/10. -39 divided by -10 is 39/10. You can change the decimals if you like. Because now I can make this guy become a 0. By taking the opposite of row, or not the opposite of the number, multiply it to row 2. So that's going to be -29 times, oh, -29 times row 2 plus row 3. -29 times 0 plus 0 is 0. Oh, actually, I don't know why I'm doing that. These are all going to be the same. So -29 times 0 plus 0 is 0. -29 times 1 is -29, plus 29 is 0. And here's where a calculator is going to have to come in for me. So I get, oh, just want a regular old basic calculator here. Clear. All right, so we're going to take 3/10 times 29, which is 8.7. -8.7. Plus row, so plus to -2 gives me -10.7. So now I get 29, -29 times 39 divided by 10, -113.1 plus 81 comes out to -32.1. All right. It's getting ugly, but it's going to get cleaned up here in a second. So now I'm going to take row 3, and I want to do the same thing. I'm going to divide by -10.7. It's 1, 4, -1, 16, 0, 1, 3/10. Going to make them in decimals. This is 0.3. This is 3.9. 0, 0. -10.7 divided by -10.7 is 1. Now let's take this -32.1 and we're going to divide that by 10.7 and we get 3. Nice clean number. Now my goal, so again, my goal there was to make this guy become a 1. Now I'm going to kind of double up my work. Actually, I don't know if I can. My goal is to make this one a 0 now. I was thinking maybe I can make this a 0, but it might have to go this way with it. So you have to kind of, that one has to be the last one. Ooh, never mind. I can do both of these at the same time because I'll just use this equation and this will become a 0. All right, I'm over here talking. But here we go. So I'm going to do I'm going to use row 3, and I'm going to multiply it by the opposite of these numbers. So negative 0.3 times row 3 plus row 2. And then I'm going to do, I'm just going to do row 3 plus row 1. And that'll be the new row 1. Here we go. So row 3 is good to go. So here's the issue. See, I would have stopped here, and I already have my z, and then I would have gone and back substituted and found x or y and x. The issue is with Gauss-Jordan elimination, you have to go all the way with it. So everything has to become a 0. That's why it's not my favorite. All right, so here we go. So I'm going to do this one here. So negative 0.3 times 0 plus 0 is 0. Negative 0.3 times 0 plus 1 is 1. Negative 3.0, negative 0.3 times 1 is negative 0.3 plus 0.3 is 0. And then now we have negative 0.3 times 3 plus, now we're going to say that's plus 3.9, and that gives us 3 on the dot. So now I know what y is, and I just got to figure out what x is. So in this next one, I'm going to just do 0 plus 1 is 1, 4 plus 0 is 4, 1 plus negative 1 is 0, 3 plus 16 is 19. So now my last step, all this work, is to make this guy become a 0. And so the way to do that is use row 2. So I'm going to do the opposite of that number. So negative 4 times row 2 plus row 1 will give me my final answer. So negative 4 times 0 is 0 plus 1 is 1. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 0 plus 0 is 0. Negative 4 times 3 is negative 12 plus 19 gives me 7. So therefore, that's what my x, my y, and my z is. So therefore, x is 7, 3, 3. So instead of stopping here and doing substitution, you go a little bit further, and then the matrix will eventually give you the full answer. But that process that I just did works every time. So let's do it again. Actually, we'll look at number 83. So we have x plus y equals 4. Y plus 3z equals negative 1. 2x minus 2y plus 5z equals negative 5. So I get 1, 0, 2, 1, 1, negative 2, 0, 3, 5, 4, negative 1, negative 5. So do notice if you're missing the letter, I plugged in a 0 for that. All right, so a lot of this actually is done for us, quite a bit. So that's going to make life a little bit easier for us. So this is a 1, this is a 0, this is a 1. So my goal right now is to turn this into a 0. I'm not going to be able to do this one to a 0 at the exact same time. It's a bummer. But I'll take the opposite of this number and multiply it. So that's going to be negative 2 times row 1 plus row 3. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 1 is negative 2 plus negative 2 is negative 4. Negative 2 times 0 is 0 plus 5 is 5. Negative 2 times 4 is negative 8 plus negative 5 is negative 13. Now I can make this one become a 0. So now I'm going to take 4 times row 2 plus row 3. So 4 times 0 plus 0 is 0. 4 times 1 plus -4 is 0. 4 times 3 is 12, plus 5 is 17. And then 4 times -1 plus -3 is -17. Now my goal is to make this become a 1. So I'm going to do row 3 divided by 17. 0 divided by 17 is 0. 0 divided by 17 is 0. 17 divided by 17 is 1. -17 divided by 17 is -1. So now I know what z is. This one's already a 0, which is nice. The only other thing I can do is turn this one into a 0. Can't quite turn this one into a 0 yet because I need this one to be a 0. So I'm going to do, let's do -3 times row 3 plus row 2. So -3 times 0 plus 0 is 0. -3 times 0 plus 1 is 1. -3 times 1 is -3 plus 3 is 0. -3 times -1 is +1 plus -1, which is 0, right? -3, nope, I did that wrong. Hold on. -3 times -1 is 3 plus -1. There we go. So 3 plus 1 is 4. Knew when I said it out loud, it didn't make sense. All right, so 4. And then that first row stays the same. 1, 1, 0, 4. Now I'm down to just the last step. So in this case, I need to make this guy become a 0. So I'm going to do negative row 1, oh, row 2 plus row 1. -1 times 0 is 0 plus 1 is 1. -1 times 1 is -1 plus 1 is 0. -1 times 0 plus 0 is 0. -1 times 4 is -4 plus 4 is 0. So there's my final answer, 0, 4, -1. Think I might have made a mistake. 0 plus 4 definitely equals 4. If I back substitute it here, 4 plus -3, because that's what that would be, gives me +1. All right, let's start off by, did I write it down right? 1, 1, 0, 4, 0, 1, 3, -1, 2, -2, 5, -5. Did I write it down right in the book? All right, so let me make sure I turn this one into a 1 by multiplying this by -2 and adding it. So -2, okay, okay, okay. Okay, so I'm good here. So -3 times -1 is 3. Oh, there it is. And this is where I thought I made a mistake the first time. All right, so -3 times -1 is 3 plus -1 is 2. 2 is the answer here. So this is 2. So this is going to be a 2 and a 2. So let's see what happens here. Because now when I do -2 plus 2 gives me 2. With so many steps, you always do want to check your work there at the end, and it's real quick to check. You just plug it in. So 2 plus 2 is 4. 2 -3 gives me -1. 4 -4 that cancels. -5, perfect. Yep, that's it. All right. So again, good thing to back check and make sure you get it right. Because again, I was wrong right at that last step there, and I did it in my head twice and still got the wrong answer. So even the simplest math can get you. Other than that, that is all I got for this video. Um, as always, if you have questions, keep emailing me. Other than that, I'll see you in the next one. Bye for now.